Uh, Apparently, this meeting is being recorded. That was surprisingly loud. All right.
That was a message from the big brother, yeah.
Yeah. Anyway, thank you everyone for joining us for the following hour or so. It is our evening local time, so thank you for taking time out of your day to join us this evening. My name is Shlomi Ovadia. I am a senior account manager here for WinDriver, and I'm joined here today, or I am joining rather, Uriah Bertal, our WinDriver R&D manager. What we're going to be covering today is developing drivers for SoCs and PCIe plus host devices simultaneously. So we're going to be showcasing some new functionality from WinDriver. If you've been with us for a while and you're familiar with WinDriver, if you attended our previous webinar, some of this will be familiar territory. If this is your first visit or your first foray with us, I hope you enjoy it, and I hope you take some some interesting insights from it. I would like to draw your attention for just one moment to the chat. So the chat will have a link to a meeting scheduler with me. So if there is anything anyone in the chat would like to set up a meeting for, if there are any topics that you find interesting that you would like to explore more in depth, please feel free to schedule a 15 or 30-minute call with me. My schedule is up there, and I'd be happy to talk to any one of you about anything that you find interesting, WinDriver related or otherwise. Again, I'm always happy to have interesting conversations with interesting people from around the world. With that preface out of the way, I'm going to throw things back to Uriah to get us started, get the ball rolling, and take us through a brief overview of what we're going to do. And Uriah, ball's in your court.
Thank you very much, Shlomi. And I also would like to, on a technical note, say that there is also a Q&A section in your webinar Zoom window. And if you want to ask questions in the Q&A section, you feel free to ask them there. And in the end of the webinar, after we finish our presentation, we will try to get to all of them and answer them. So feel free to write there any questions, comments, whatever. All right. So let us get started. So today we're going to discuss the following topics, but in general, what we're going to talk about is designing drivers for hardware products. So in order, and like this part, but before we can make a driver for a hardware product, first of all, we need to discuss two layers that come before the driver, which are the physical layer and the logic and design layers. So we're going to cover that very quickly in the beginning of our presentation on the FPGA overview, and then most of the presentation is going to focus on the driver layer, which is it's a little bit higher than the hardware layer. That's the layer where the physical devices actually communicate with the operating system and allow people to actually use them in the user applications. And after we're going to cover the basic part of physical and logic layers with the FPGA overview, I'm going to hand it over to Shlomi to introduce WinDriver, our product, and talk about what it is and explain a little bit about the DMA samples that we provide. And then Shlomi is going to show you a demo of our GUI. Our GUI application allows you to create drivers within a matter of minutes. And what's actually going to happen is that Shlomi is going to create a driver for you online, live.
This wasn't in the script. There was supposed to be a video for me to play. I thought I need to talk to my agent. I need to talk to my agent.
You're going to do it live, Shlomi, live. And he's going to show it actually on a platform device, on an SoC by Altera. And after that, he's going to generate code from the driver. Like he's going to show that on the GUI, and then he's going to generate code, and I'm going to compile the code. and run the application, the resulting application, both on a platform device, on an SoC, and on a PCI device. It's going to be interesting because both the platform device and the PCI device are going to have the same hardware logic, but they will be identified as two different kinds of devices. One is the PCI device and one is the platform device. So with that said, let's dive right in. So what's an FPGA? Let's get a quick reminder. An FPGA is a field programmable gate array. It's a semiconductor device that allows users to reconfigure its internal hardware circuitry via software after manufacturing. So you don't need to remanufacture your device every time. You can just reprogram this chip that I'm pointing to, and then you can actually reuse that exact same device for many, many different usages, and also to debug or to improve your hardware design. So the advantages of using FPGAs are modularity. They're used for prototyping. They're used for research and for distribution. So you could also, after you get your finished design, you could also just program that on your FPGA and distribute it like that. And the fields that FPGAs are used in are many, many fields. I'm going to cover just a few: hardware acceleration for AI, telecommunications, fintech, Bitcoin mining, and other crypto mining stuff, and also image processing and other, let's say, signal-related stuff, processing like audio, video, image processing, and the likes. So FPGAs actually come in two main different configurations. One is this configuration, which is a PCIe device. How do we know it's a PCIe device? Because it has these teeth, these gold teeth, and they connect to a PCIe socket. And then on a host computer, this thing identifies as a PCIe card, and then that configuration is a configuration that the operating system on that host computer can work with. On the other hand, this is what we call an SoC, or a SoC, system on a chip. And that's actually, this and this are the exact same chip, but this SoC also has a CPU, so it could also run its own operating system. It has its own memory slots, and it has all these other connectors. But as you see, it doesn't have these gold teeth, nowhere to be found. So we cannot connect this into a host computer, and this cannot identify as a PCI device on its own. But when you program the exact or very, very similar logics on the FPGA, on the SoC, it can identify as a platform device on Linux. And this is what we're going to touch today, how to take the same logic and use it both as a PCI device and program it on something that looks like this, and also how to program it on an FPGA that looks a little bit like this, and how we can create a driver for both configurations at one time. Like, we don't need to rewrite the driver, even though the configurations are very different from each other on the operating system side. So this is what we're going to cover today. Let's talk a little bit about usages of SoC FPGA. So if you don't need a host PC connectivity, you don't need a huge box with a huge operating system. You just need this little board that could fit into the back of a car, or you could put it in the field.
On a plane, in a train.
Exactly, yeah. So it's much more smaller and allows you to make it much more compact. And you can take your hardware design and apply it to an SoC configuration, and vice versa, like switch it around between a PCI configuration or a SoC configuration and just go back and forth. It does require some changes on the hardware and design side, but we're not going to cover them too much today. But in general, the main logic should remain the same, and shouldn't be too hard of a problem to go between this configuration and that configuration, assuming that you're using the exact same On this example, both of these FPGAs are actually Altera Agilex 5, for example, so that shouldn't make a difference. But if this was AMD's and this was Altera's, that was a different story, of course. I just want to clarify that. Okay, so we have a little poll for you. I'm going to take a minute to fill it out before we continue. So we want this webinar to be an interactive one. So let me just open it for you. Just a moment. Yep. So you got a minute to answer the following question, and I'll say it. Which FPGA vendor are you using or planning to use in your next project? So we see right now there's a majority. Well, I don't want to say actually the results before our time's out.
Don't skew the results.
Yeah,
Don't skew the
I'm not
results.
skewing
Let
it.
people.
You say whatever you feel, guys and girls.
Whatever's in your heart.
Yep. Okay. You have 25 more seconds and only 50% answered. So come on, we believe in you. You can do it. All right, 3 more seconds to go. All right. Okay, so we have 67% of the webinar participants answered the poll. And I'm just going to say that the results are 57% use AMD Xilinx or plan to use AMD Xilinx FPGAs. 26% plan to use Altera's. 9% Lattice. 4% others. And 4% I don't use FPGAs. And Microsemi 0. All right, so let's carry on. And okay, so we've covered a little bit about the physical layer. I want to cover the logic layer really in a hindsight. So after you choose which configuration you want to use, either if it's the PCIe configuration or the SoC configuration, you need to actually make your design. How do you make your design? It depends on your vendor. If you're using boards made by Altera, then of course you will need to use Quartus. That's their IDE for hardware designing. If you're going to use AMD Xilinx, you're going to use Vivado. If you're going to use Lattice, you're going to use Radiant. And we're not going to get too deep into that, but there is one thing that I want to share with you before we carry on. And this is our example design section. So Lomi, do you see that now if I'm sharing it?
Yes.
Yeah. So if you go to our website, the WinDriver at windriver.django.com, and you enter you click on my portal here, you get to this window, to this page, sorry. And in this page, this is the customer portal, and it allows you to do all kinds of things like have a pricing calculator, meeting scheduler that Shlomi just mentioned in the beginning, other news and events, upload documents or suggestions that you want to give us. And this section is called the example project section. So let's click that. And here we get a number of projects that we've made for you in advance. And you will be able to download these example designs for Altera, Agilex 5, Agilex 7, Cyclone 10, Aria 10, and AMD Xilinx Vertex UltraScale Plus, both XDMA and QDMA. And what's nice about these is that whenever you want to start a project and you want to make sure that everything just works out of the box, and if you have any of these part numbers, you can just download the designs we already made. And if you use these exact designs, this gives you 100% probability that they're going to work with our driver samples.
He
Shlomi
never
is gonna.
says 100%. He never says
Yeah,
100%.
yeah,
I'm glad this is recorded.
yeah. Well, we tested all these with these, so I mean, at least on our computers they work. That's what I can say. But if they don't work, then you can always contact Shlomi or me, and we'll help you. But in general, we get a lot of customers asking, okay, I'm trying to, for example, work with your XDMA sample, and it's not working for me. What should I do? And I say, okay, you should play with your design and do this and this and this and this and this. But that's like a long thing to tell a customer or an evaluator, where you can just download this design, and this design works perfectly with this sample. So Shlomi is going to cover our samples in a couple of slides, but in any case, if you really want to get started immediately with our samples and our drivers, then using these example hardware designs could really get you there fast. So that's a recommendation that I strongly recommend. And I just want to make sure that we're back into the slides. So do you see the slides now, Shlomi? Is that okay?
Yes.
Okay.
Yes.
So now, after covering the logic and the physical part, we're going to get to the driver part. And for this, I'm handing the mic to Shlomi.
All righty then. So, as Uriah went through the various stages that will inevitably lead us to a driver development project, this really is where we come in, or where WinDriver comes in. Now, in order to understand really what the benefits of WinDriver are, what are the problems that it solves, basically, what are the benefits to using WinDriver, it's very important to understand what WinDriver is first and foremost. So first and foremost, what WinDriver is a driver development toolkit. It basically takes most, if not all, of the difficulty out of the driver development process. So whether that's with the availability of it working with every PCI, USB, and now platform devices configurations, and it being generally cross-compatible between any of these, which we're going to demonstrate in just a few moments. The customizability of how easy it is to scale APIs as well as adjust them and fix them. How easy it is to do with a GUI application, our DriverWizard, which again I will be demonstrating in just a few moments. And I'm going to immediately say that Uriah is going to say that if I can do it, if someone like me can do it, then of course you can do it. So I'm going to preface it by saying it first, that if I can do it, then you can do it, particularly in our easy to use GUI application, which basically allows you to do a significant portion of your kernel development processes in the user mode. And I'm going to show that in just a few moments. And it's cross-platform compatibility. So WinDriver is entirely cross-platform compatible between Windows, Linux, macOS. We're starting support for Zephyr RTOS, as well as, it's not on here, Windows ARM and even Linux ARM and even Windows ARM. And we're always adding support for new things. So if there's a configuration or a operating system or something that you would like to see that you don't see here, please do feel free to put it in the chat, or send us a message at the end of this. So it's something that we can keep in mind as we move forward. And one more thing to mention here, as we said, we do have some enhanced support or specialized support for some of the more popular FPGA cards. And we're going to talk about that in just a moment as well. Slide. So here we see a small snippet of the various layers that WinDriver has. Again, if you're an old hand at WinDriver, if you've been here before, then you're probably very familiar with this. The main section here is the DriverWizard, the GUI application. Over to the right, in the top right, you can see a compiled user application. Uriah, correct me, I believe this one is for Windows, while today we're going to be demonstrating the Linux version of this. In our previous webinar, we showcased the Windows version, but again, these are very similar. And as I mentioned, they are pretty much cross-platform compatible, nearly as is. And right beneath that, you can see a small smattering of the code itself, some of the APIs and registers that WinDriver provides. Now, we're not going to cover any of these except the wizard terribly in depth today. Again, just for lack of time. But we do have many resources on our website, a full-fledged evaluation, free evaluation. Everyone loves something free, right? So there is a 30-day free evaluation with full technical support when you can really delve in to all the nitty-gritty details of this. So you can see all this for yourself. You can experiment with it. You can play with it. And it comes with full technical support. So any issues you have with WinDriver, we're here to help. And it's all in-house support. From there, I think we can go on to the next slide.
I'd just like to add that even though Shlomi is not covering the code today or the user application today in a lot of depth, we have like previous webinars available on our Academy section on the website and also on our YouTube page. So if you want more information, you could always go there as well. Yes.
Yes, webinars and short form videos. So if you don't want to sit through a whole, 45 minutes to an hour, there's plenty of short form video that's 2, 3, 5 minutes to cover various different features and functionalities. And we're going to be adding to that substantially very soon. Now, when we talk about WinDriver, as Uriah explained, there are the DMA samples, or rather, as Uriah explained about the example projects. So those are hardware designs that will allow you to burn your device with a DMA compatible hard IP. From there, what you would need is you would actually need the example code or the code that would go along with that. And that is what our samples are. They're sample code for the popular DMA IPs that the example projects are matched with. So once you have the hardware design set up, this is where the samples come in. Now, the samples comes with various features and functionalities to allow you to actually test them, experiment with them, and see sort of where you stand. They come with everything that you see here. I'll just rattle them off real quick. Performance tests. So rather than just trusting our numbers, we encourage you to take advantage of the performance tests and see how they function on your devices in your configurations, in-house for you. Customized DMA IP data, basically everything that you need to get your DMA IP up and running. Interrupt handlers, DMA mechanisms, kernel plugins, and everything along those lines. Again, all of these things or most of these things are covered in previous webinars or in our short form videos, as well as in our very robust and well-reviewed user manual that is quite popular. Slide. I love being able to boss Uriah around with the slides. I love that he has control and I have to tell him to do it.
That's the only time he can actually boss me around. Okay,
pretty much. I'm going to take advantage of it. So regarding our DMA samples, so we really do try to cater to as many of the larger players in the field, be they Xilinx AMD, Altera, Lattice, or sort of older platforms like the PLX cards. Now, when we talk about the specific DMA sample IPs, you'll see that we have a bunch of different ones, whether they're the tried and true ones, the ones that are most popular, like the XDMA from Xilinx, whether it's the Avalon or MCDMA from Altera, the Avant Certus Pro from Lattice, or the PLX that you see on screen. So we offer samples for all of these different IPs. And in the upcoming version, which is supposed to be released right around my birthday, right, Uriah?
Yeah, about a month from now. Yeah.
About a month from yeah. No, you can shoot for April. April's good for me. Early April.
2nd. Almost April Fools. Yeah.
Almost. I'm almost a fool. We will be also adding support for some platform device examples, like the Oxy DMA from Xilinx and the MSG DMA for SoC for Altera cards, for Altera platform devices. Slide. So as far as the enhanced support that we were talking about, like we said, these are devices that we will generally have tested in-house or have very concrete customers and clients that have we've either worked with them on their cards or they've sent them in for different testing, etc. Be they, again, the latest and greatest from the bigger players like the Versal AI Core from Xilinx, the Agilex family of devices from Altera, the 5, 7, and 9, the Avant and Certus Pro from Lattice, or any other FPGA or PCIe card that you may have. So while we are putting quite a bit of stress and emphasis on these bigger players, it is important to remember that WinDriver is what we consider to be silicone agnostic. So it does not care. WinDriver is not concerned with whether you got your hardware from one of these major vendors, whether you built it yourself in your garage, or whether you're using some other third-party vendor that may not be on here. As long as it will identify as a PCI card or USB device or soon to be a platform device, etc., etc. As long as it's a supported platform, WinDriver will recognize it and it will be a viable solution for your driver development needs. Slide. So regarding our upcoming features, this is really Uriah's bread and butter, so I'm not going to steal his thunder on upcoming features. So I will toss it back to you, and please tell us what's in store.
Okay, so in about a month, we're going to release a new version, as I previously mentioned, Shlomi previously mentioned, and that version is going to support also SoC platform devices running on Linux. So that means actually that you'll be able to take designs that are running on SoCs like we've shown before, and use WinDriver to create driver for them as well. WinDriver is a very experienced product, and we've been in existence for almost more than 25 years, and
almost 30. Almost
30, yeah. And most of the time we supported ISA, PCI Express, USB, but we didn't have support for SoC platform devices up until now. So this is a breakthrough for us. So let's talk a little bit about the SoC platform device workflow. What do you need to do in order to make your device work with WinDriver, or that WinDriver will be able to identify it? So first of all, again, on the hardware side, you need to fit your design for SoC. Just like I mentioned before, you should make your hardware design be programmable on, for example, this Agilex 5 by Altera. Just an example. But if you're going to use AMD Kriya, then of course you need to suit it for AMD Kriya and use the right tools for that, including Vivado and so forth. Once you fit your design for SoC, you need to program your SoC's FPGA. That's also something that you need the IDEs from the vendors to do that. Then you need to make your platform device identifiable by your operating system. That usually is something that also comes with the IDEs. But we're also going to make a feature that allows you to add your platform devices using WinDriver so that the operating system will be able to identify them. And then if the operating system will identify them, then WinDriver will be able to identify them. And in the examples that we're going to show today, we have already did all these preliminary steps in order for the operating system to identify the platform device that we're going to work with. So after you've done all these preliminary steps, you can just use, and that's the good part, use the same WinDriver-based driver you would use on PCIe. No need to change the code. No need to change almost anything, and I'm going to prove that to you in a couple of minutes. So assuming that your design is exactly the same, and it has the same offsets, the same APIs, then again, the programs are going to work almost exactly the same, and we're just going to show that. So if I need to summarize, our slogan is we either do it for you or assist you and support you in doing it on your own. Like if these two parts are not that easy for you, even though they're not part of our product, but we still have an in-house FPGA engineer that can also provide support and help you with these two steps if needed to make sure that your project is moving forward and you can use WinDriver for the easier part of developing a driver, and Shlomi is soon going to show you how easy that is. So which device are we going to use today? So what we're going to use today to exemplify all these beautiful things that we've been talking about for a while is a device called the EDU or EDU. And it comes originally from QEMU. QEMU is an open source project, short for Quick Emulator, originally written by Fabrice Ballard. And now it's a community project. Originally, it was a virtual device, but our in-house FPGA engineer actually made a physical device out of the same logic, and
With magic.
yeah, built
With magic.
a design for eDO that works on Altera devices, on AMD devices, on Lattice devices. So we use that for testing and for playing around and checking our driver in many different situations, and it does a lot of things. But today we're going to focus only on two functionalities just to keep it quick and simple. The first functionality is if you write some number to the offset 4 of your MMIO space on the device, then it will be a simple value inversion. So it's, let's say you write all zeros, it's going to become all ones, or in hexadecimal, all Fs. If you're going to write all fives, it's going to become all As. If you're going to write all As, it's going to become all fives. So we're going to exemplify that in a moment. And also, we're going to show how you can raise an interrupt. So with eDO, it's very simple to raise an interrupt. You just write to offset 60, any value you want, and that value just raises some interrupt. And then that will be, then by doing that, we'll be able to show you how WinDriver intercepts interrupts. In these examples that we're going to show today, it's just going to print a little message saying got interrupt. But in general, WinDriver allows you to put any callback you want. So if you want to send a rocket to the moon, once an interrupt is being intercepted, then you can also do that because you have a free hand in writing your own interrupt callbacks. So that's a very, very nice thing and pretty easy to do with WinDriver. There is a great video again on our YouTube page with Shlomi actually exemplifying how he changes the interrupt handler in the Embedded World conference about 2 years ago.
Which we will be attending this year as well. So
yeah.
please, if you happen to be in Nuremberg for this year's conference, we'll put the details of our booth in the chat as well. And if you happen to be in that area while the conference is happening, come say hi.
Yeah, so if you happen to be in Germany in about a couple of weeks from now, then you're going to see Shlomi live. Not me, but Shlomi. And so we're going to go to the demo now, but just to finish talking about eDO, so we're going to show two configurations of the same logic, this logic that I discussed, both as a PCI device and as a platform device. So Shlomi, the stage is yours.
Dun, 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 dun. All right. So I will share my screen.
Shlomi is going to show you the actual DriverWizard live.
We'll do it live. All right. Can you see?
Yeah, I can see that.
Fantastic. All right. So, as I've mentioned before, if you are an old hand at WinDriver, this should look fairly familiar to you. This is the DriverWizard. Now, again, if you are quite experienced with WinDriver, this may not look quite right. The reason for that is that this is the platform device version of it. Now, we're going to hop right in, and we're going to show you what's new. So, as we go right ahead and open a new device, you're going to see that we have several devices. Again, if you're used to WinDriver, this should look fairly familiar. You can see a little bit of information about each device here to the side. And here we're going to grab one of our platform devices. So this is the eDO platform device. These are two instances of the same card. Correct me. If I make any mistakes, please correct me, Uriah, and I will, deal with you later.
I see the device is already open, so maybe you closed first. That's
Oh, is it already open?
Yeah.
Well, all I would have to do is select one, and I would be here, where you can see that the device is already open.
Yeah, or maybe you can close the project and just do a new one.
Sure, let's do all the things you want to do. So as we close the project, I can go ahead and pick one of these devices at random. Let's do 5 and cancel it again. There we go. And I'm going to click next. There. So Now that we've selected the device, it's going to take us to the spot where we can see all the resources the device has to offer. So here we can see that we can listen to interrupts, which we're going to start doing. And we can see that we have one bar. Now, one of the features we wanted to showcase today is actually a feature that, as Uriah has already pointed you in the direction of that video, that was the unveiling of this feature. But it's since been honed to something that we've gotten more feedback on. Customers have given us more use cases for, and we've seen it received very, very well. So we wanted to circle back to it, and that's the PDAs, or the predefined actions. This is Uriah's personal brainchild. This was a feature that he implemented and I believe is very proud of. So we're going to go ahead and try to do him proud by implementing it live. So the first thing we need to do is we need to add our access registers. So I'm going to go ahead and add some access registers here. And we're going to call the first one. I wrote this down because last time when I didn't, my dyslexia got the better of me. RAC. So this is the interrupt raise, reg. And you'll notice I'm also putting the capital letters where they belong, as requested. Again, something I did not do when we were practicing this, and is not the best practice to not add capital letters. So we're going to go ahead and put in offset 60. That's just what we get from the device. And we're going to go ahead and do that. Now we're going to add our second access register right there. And we're going to call that one invert reg. And that one's going to write to offset 4. That's for our inversion. And we're going to go ahead and set those two up. Now we're going to set up our predefined action, and we're going to call it, let's say, invert and int. There you go. And we're going to add that as a new predefined action. From there, we're going to start adding our transfer commands. Okay, so the first one is going to be our invert. We are going to write, and we are going to write 55,555,555. Yes, I practiced that so that I would get that number correct. We're going to add our second transfer command, which is just going to be to read from that same offset, and our final transfer command, that is going to be our interrupt. Int raise, and we're just going to write 10. Doesn't really matter. So as we are listening to interrupts, you'll notice that I have this set up to perform some operations and start interacting with our device, with our platform device. And now all I'm going to do is I'm going to press this button here of run the flow. As I run the flow, you'll notice that my 55,555,555 has inverted to ah. And you'll also notice that when we wrote to offset 10, oh, why didn't I get my interrupt? Should I have done a read? Uriah, what did I do wrong? There it is. So the interrupt is asynchronistic, so this may have just been a false output, but there you go. You can see that I got an interrupt. Oh, I didn't scroll down. That's what happened. I didn't scroll down the log. And because I made it longer than last time, I screwed it up. But it's fine. You can see here that we ran the flow and we got the interrupt. As it's asynchronistic, you can see that it came after we ran the flow, but that's just how the output looks. From there, once we have this environment set up, I would like to draw your attention to one other fact about it. I did not write a single line of code. I did not have to adjust anything. I did not have to edit anything. I didn't have to change anything about the actual card or configuration. I did everything with a GUI application. Yes, I had to change some. I had to tell it what I wanted to write, but that was about it. From there, what we're going to do is we're going to generate our code. And this really is where the magic happens. Again, if you're an experienced WinDriver user, you know that this is where our samples come in and where you can choose the various code generation languages that we offer. But currently, we're going to stick to ANSI C, and we're going to do this in CMake. We're going to go ahead and click OK. And again, for all you old hands, you'll notice that we have a new box to tick here. Generate application compatible with both PCI and platform devices. So this really is sort of the new feature the team has been working on, or one of the new features the team has been working on. And we're going to go ahead and generate that project. And we're going to go ahead and call it T2000. And we're going to save.
Not 55 million.
No, no, no. I wanted to do T1000 for the Terminator series, but yeah, I didn't know if I'd get like a copyright strike or something. So
All right.
we'll leave it at the T2000. Next time. All right, so here we see a list of all the files and folders generated for the project. And from there, I am going to toss it back to Uriah to actually show you what all of this means and what your next step would be if you wanted to continue to edit your project from here. We do have users and then people that use WinDriver that stick to the GUI and really use this for the vast majority of their work. But if you do want to take it that step further, or you need to do some other editing or anything like that, totally up to you. And Uriah is going to show us a little bit of that right now.
Can you see my screen with the terminal?
Yes, we can.
Okay, so it's a terminal. Okay, so
The terminal makes me terminal.
Exactly. Yeah, this is why I'm doing this part. But even I mean, I'm a software engineer, sorry, but I believe that even Shlomi would have been able to do this part as well because it's very easy.
Even
Shlomi, yeah.
I could do this. It would take me the better part of the next hour or so. So that's why we're letting you do it.
Because we're gonna run just very few commands. First of all, we're just gonna compile, like create this CMake project. And
there's 20 minutes for me right there.
No, the thing is that you need to, first of all, we need to change the ownership because we were running a sudo, so change the ownership of this directory. Yep. Now we'll be able to run the exact same command. There we go. And if I run make, it just creates, instead of, usually if you would have run CMake with WinDriver before, then you would have just got this one target. But now you actually get two different targets. You get the PCI code and the platform code. But something very interesting, because actually if you look at it, you see that we have diagonlib.c, just like we had before. So actually, you actually don't need any new files or no new big changes. It's actually the exact same code here and here. And the only difference, if we actually look in the CMake lists file between these two, to look at the difference between these two targets, is that here we have the PCI target and we have the platform target. And on the platform target, we only have added this platform API define. That's all. That's the only difference between the code in these two applications. And voila, it's just going to work like this. So I'm just going to run it and see how it goes. And practically, we're going to do the exact same things that Shlomi did in the wizard, but now on a C application. So here, so it already opened the edu device for us. And again, we have some functionalities that we can do. But first, I'm going to cover the things that Shlomi did on the wizard, like enable interrupts, so we could actually intercept the interrupts that are going to be raised. And he created a predefined action flow and called it invert and int. So why don't I just run it,
And if I did my job, then nothing will be set on fire.
Yeah, and we actually have a lot of experience setting the devices on fire here, but currently nothing went on.
Two times it happened.
Yeah, and actually nothing went on fire. Nothing went on fire today, and it actually worked exactly as it worked on the wizard. So you actually have generated a code that does this flow the exact same way. You write 5s, you read A's, you write 10 to the offset 60, and then you get an interrupt raised. So again, all of this was done without my intervention, and I didn't actually write any code here, at least not in this session. If we go to menu 7, then we can also look at these registers and play with them. So for example, we can read all of them, but let's do a simple inversion again. So if we want to, let's say, do this inversion, and I want to turn these Fs into a 0, then and then I'm going to read, and and then we get a 0 because we wrote Fs. If we want to raise an interrupt, then we can just write again to the interrupt raise register, and voila, we got an interrupt. So that's a nice example showing how you can just name areas in your device or in your memory sections and just use them very easily and create a very, very easy to use application without any coding at all. So that was a platform device, and like assume this was running on an SoC. And now we're going to take the exact same code and run it on a PCIe device. So actually, what's interesting is we already saw that in the wizard, but we have this device here, which is a PCIe version of eDO. Up until now, we were using a platform version of eDO on this application, but now we're just going to open the PCIe version and run that second target that we made, T2000 PCI. And this should work exactly as the PCI diag used to work on previous WinDriver versions. So we could just open that. And again, we have the predefined action flows. If I run that, again, we get exact same results. Note that I didn't enable interrupts, so we didn't get the interrupt received message. So I'm going to enable interrupts, and now I'm going to do that again, and boom. So
and it's yellow.
And
it's
it's
yellow.
Exactly. So
2 years I've been asking for the output to be colored.
Yeah, that's also a new feature, the yellow
A new feature.
interrupt callback. But notice that this is exactly the same thing. Note that here we have MSI because this PCI device has MSI interrupts, while the platform device had edge triggered interrupts. Sorry, level sensitive interrupts. But on the driver side, we know automatically which interrupts are enabled, and we just know how to trigger them. And it doesn't really matter on the driver side for WinDriver. And also, again, the registers, I'm going to quickly do that same thing again, invert something. So let's invert all these A's into 5s. And
you mean voila. 55,500,000.
Exactly. And let's raise an interrupt. So, and we got an interrupt. So that was a very quick demonstration of how this exact same code, these exact same files like diag.c and libc and libh could actually be used interchangeably between platform devices and PCI devices. Only thing you need to do is just click that button in the additional options window that Shlomi ticked. And when he ticked that checkbox, you got this generated code that is suitable for both platform devices and PCI devices. So in your process of development, if you just want to switch between configurations, then you can be assured that on the driver side, it's going to be very easy if you use WinDriver. And of course, you can take that code to Windows and to macOS and so forth, just like we previously mentioned. So that's the end of the demo. And we have a few more things to show you before we finish our webinar for today. So let me just change what I'm sharing. So Shlomi, can you see the slides?
No, right now it is blank.
And
there
now?
We go. Now I see
okay,
poll 1 minute.
Yeah, so now we're going to have a second poll. And I'm going to give you a minute to answer that. And the question is, which configurations are you planning to use in your upcoming project? You may choose more than one. And you have 1 minute to answer that. And the options are PCIe plus host, SoC only, cloud, or other. So remember, we also this is something that we covered in our previous webinar that could be found on YouTube and on our website. We're also coming up with a cloud FPGA configuration of WinDriver. So if you're interested in that, we will not cover that in this webinar, but you can contact Shlomi, and he could also tell you how we can allow you to create FPGA cloud projects with WinDriver. All right, so we're waiting for all participants to answer. We'll give you a couple of more seconds to do that, even though.
And while we're doing that, you can check the chat again. I put the dates in for Embedded World as well as our booth number. So if you happen to be in Nuremberg for the exhibition, you can find us there at booth 4 dash. I see that some people can't see the poll. Uriah, any ideas?
That's
If you can't see it, you can go ahead and toss your answers in the chat, and we'll appreciate that as well. But for Embedded World, if you happen to be in Nuremberg between March 10th and March 12th, so we will be there the 10th, the 11th, and the 12th. We'll be in Hall 4, booth 632, Embedded World 2025. We're very excited to go, and I honestly do hope that I get to meet some of you guys that attended the webinar live. I always like meeting people in person. We'll have snacks, which is always fun, and I plan to go off my diet while we're there, so that's good.
All right, so I'm going to mention quickly the results of the poll. So we have PCIe only 31%, SoC only 69%, cloud 15%, and other 8%. So thank you very much for answering. And again, feel free to write in the chat if you were not able to see the poll for some reason. And so we just want to conclude before we wrap it up for today. So what did we do? We used the same hardware design logic on two different configurations, PCIe and SoC. And we showed you how WinDriver can open a platform device. It could also open a PCIe device. We didn't do that in this webinar, but you can see videos of Shlomi doing that in Embedded World 2 years ago, or other videos that we have on our website or on YouTube. So we didn't want to make it too long, but you can also open PCIe devices on the Wizard and USB devices. But today we wanted to show the SoC configuration because it's a new configuration. And we generated code that was suitable for both configurations at the same time, allowing you to really have one code and just leave all the troubles for us, basically. So that is it. Thank you very much for joining. And Shlomi, if you have any more words to say.
Yeah. First of all, before we start answering some of the questions that popped up in the Q&A section, first of all, Mike, I will hold you to that. I hope to see you there. Let me know what your favorite snack is, and I'll be sure to bring some for both of us. I'll be sure to bring some for you too. Yeah. So again, thank you very much, Uriah, for all the technical specs and for helping me prepare for this. Thank you, everyone, for attending. Again, there is a meeting link in the chat. I will drop it there again for anyone that would like it. There it is. There's our meeting link again. And again, the information for Embedded World is right there. In the meantime, Uriah, if you could please take some of the questions that were asked during the show, during the webinar. And again, please remember, we do offer a free 30-day evaluation of WinDriver, not the SoC, because that is still sort of a preliminary beta phase. But if that is what you're interested in, please reach out, and I will hook you up with the SoC beta to test and try and get to work with it. But if you're doing anything with PCI, if you're doing anything with USB, please take advantage of our free evaluation and see what WinDriver is really capable of. Again, full technical support from our in-house engineer, including Uriah himself.
All right, so I will answer. I think there were two questions, and it seems to me like they are coming from the same person, even though that's an anonymous question. So
Anonymous is one person. What do you mean?
yeah, no, maybe there were two anonymous attendees, but it seems like questions
Anonymous.
are very related to each other. So I'm gonna relate to them at the same time. So the question was, do you do drivers for DDR4, and is it considered a softcore? So in general, we provide a PCIe, USB, and platform device drivers. If the device identifies as any of these things, like any of these protocols, USB, PCIe, or platform device, then WinDriver can work with that device. If the PCIe device is, I don't know, a rocket or a disk drive or a sound card or anything like that, as long as it identifies as a PCI card, then WinDriver can work with that. So I hope that answers the question. Regarding CXL, it's pretty much the same thing. If it identifies as a PCIe card, then it could work with that. And I can just mention that we had, I personally had contact with a customer of ours that was using WinDriver with CXL. So I hope that answers the question. And if you want to get to more specifics, then of course you can set up a meeting with Shlomi. Any other questions before we wrap it up for today?
Last chance, folks. And yes, he is single.
That's correct. I also
Uriah, not me.
Yeah, I also do bar mitzvahs. Yeah,
He also does bar mitzvahs. Weddings,
that's not a joke.
mitzvahs.
I actually do that. Yeah, you can check my LinkedIn page if you don't believe me. All right.
Is that on your LinkedIn page?
It is. All right. So thank you very much, and have a great day or evening wherever you're located, and feel free to use WinDriver.
Thank you.
Talk to us.
Thank you, everyone. We hope you enjoyed this webinar. Again, take advantage of our evaluation. Come see us at Embedded World. Set a meeting with me or one of my colleagues, and that is basically it. Thank you, everyone, very much, and have good afternoon, good evening, and good night.